Hello guys, I hope you all are fine and doing great. Today we are going to discuss this queries on a string problem of GFG. So this is a dynamic problem. Let's move on to the problem. So guys, in this problem we are given a string and given a 2D vector of named as query 2D vector. In each vector we have a vector of size 2, that is, and first index contain the L, and this value we named as R. This is the left index, this is the right index, and between these two index we have to find out the number of different character in our string. Like from here 1 to 4, and here indexing is 10 base. So between 1 to 4, like this is the string. So different number of character is A, B and C. B is repetitive character, so different number of character is 3. So here is 3. Now between 2 to 4, so between 2 to 4 we have two different character B and C. So answer is just 2. Between 1 and 7, so first, second, third, fourth, fifth, sixth, seventh. Oh, okay, complete string. A, B, C. B is repetitive, so no. A is repetitive, no. So E means fourth different character. D means four different character. Fifth different character. So here total is equal to 5. A, B, C, D, E. Okay, and similarly, okay, so here is only one example. So let's move on to the problem. So how we will do it? As you can see here, we cannot traverse a loop o n square time, because here we are given some test cases, and in those test cases we have to traverse the string. So here maximum space is 26 into nth of string. Okay, means we have to store the index, and here time complexity can be up to max 26 into maximum of string, or maximum of, or total number of queries. Okay, so time complexity means we have to done the each of the queries. Like suppose if we have a query, if we have a size of a string can be 10 raised to the power 5, and queries 10 raised to the power 4. Okay, like s is 10 raised to the power 5, and queries can be 10 raised to the power 4, and each query can be anything. So suppose we have 10 raised to the power 4 queries of size L is equal to 1 to 10 raised to the power, means complete string. So total time complexity we need is 10 4 into 10 5, 10 raised to the power 5, that is nothing but that is nothing but 10 raised to the power 9. So we never be able to solve this particular problem in on time. Means if we execute the query like from lth index to rth index, we cannot traverse each time to count the different character. So what we have to do, but if we traverse each query only 26 times. Why 26 times? Because we know in our alphabet, in our English character, we have only 26 character from A to Z. Now this 10 raised to the power 5 reduced to 26. So in maximum case, in maximum roast case, means the biggest time complexity that we can go is 1026 into 10 raised to the power 4. This is the time given in one query into 10 raised to the power 4. This is the total number of queries. Okay, so I hope you will understand this. Now I must clear it. You can back the video to see. So guys, now what we are seeing. So first of all, I'm explaining you what we are doing. So A B C B A E D. First of all, I just copy all of these things. If can possible, yes, thank God it is possible. So I just make a vector of size 26, like whose index 0 means 1 A, 1 means B, 2 means C, 3 means D, 4 means E. I write here also A, B, C, D, E. As we don't need F here. Why? Because we don't have any F in my character. Else why I have a string. I have size up to Z. That is 26. This is Z. Now in zero, what we are storing in, this is the indexing. This is the indexing. Now in this indexing, what we guys are storing? We are storing the index of our 8th character, means our 0th character in our alphabet. Now 0th character in our alphabet is A, so index of A. So first index is first, it is first index, comma, next index is 1 2 3 4 5. So A is present as 1 and 5 index. Now for B is present 2. Indexing is 1 base. Okay, indexing is 1 base. This is 1. If this can be increased, I can write it. We can increase. I will reduce the size. Just give me a minute. Okay, so here it is 1, it is 2, it is 3, it is 4, this is 5, this is 6, this is 7, this is 7. Okay, I hope you will now understand. So B is present at 2 and 4, 2 and 4. Now C is present as 3, D is present at 7, E is present at 6. So total 6 index, 1, 2, 3, 4, 5, 6, 7. Okay, sorry, total 7 index. Okay, so guys, now what we are doing for each query, now for our first query, like our L is equal to 1, our L is equal to 1, our R is equal to 4, our R is equal to 4, and our C is equal to 0. What is C? C is the count of different characters. C is equal to 0. Now for A, now for A to Z, I will check. What I will check? Lower bound in my this particular vector vi vj. J is the particular character 0 to 25th array. 25th is the index of this is 25th, sorry, this is 25th, not 26, because a is 0, so j is 25th, and the index lower bound of our L. Now what is lower bound? You can check it on GFG. Lower bound will return us the first character, the first index in our this vector who have value at least L, like here it is 1, so in array it will return as 1 which have value at least L, so it will 1. Now we will check if x is equal to 1, it will return the index of this particular array. If we subtract beginning of our vj, then we got beginning. Okay, this is just the whiteboard, so I like, okay, so this is a variable x, and in x if we put like vj x, initially this is x, now we will modify x as our, if our x is any index in our vector, it is not the end of the vector, and what we do, vj to vx, we will now change vx to value. Now initially vx is equal to 0, here vx is equal to 1, the value of index 0, so it is 1. Now we will check this 1 should be greater than or is equal to L, and this x should be less than or is equal to R, means this is the index that should be lie between L and R. And if there is an index in my this array which lie between L and R, means there is a character A in between L and R. If there is a character between 1 and 4, yes, this A is between 1 and 4, so my C will become 1 now. Now I will check for my B, lower bound of 1, at least 1, is 2, so now my x is equal to 2, 2 is between 1 and 4, yes, so now my C will become 2. I will check for this, lower bound of 1, it will give me 3, so it is 3 now. 3 is between 1 and 4, yes, so I will again increase my count. Now I will check for B. It will give me 7. Now 7 is between 1 and 4, no, so I will not increase. I will check for E. It is 6, it will give me 6, so whether I will increment, no, because my 6 is not in between L and R. I will check for F. For F I will go 0, means the starting index, but this is the end of my array as well. Okay, here I will go 0, in F I will go 0, but this is the F. Like here you can see I write a condition, if my x is equal to vj dot size, as here you can see size is equal to 0 as well, so I just continue. I will not do any change. I will not doing this statement because I don't have any x index. Now similarly I will do it for all the array. So here you can see our answer is equal to 6. So for first query we can say our answer is equal to 3. Now for query 2 to 4. Now for answer query 2 to 4. Okay, just give me a minute so that I can uh, yes. So now for second query I just change the color. I will check on this, check for L. Now L is equal to 2, and R is equal to 4. R is same. r is equal to 4. Okay, r is equal to 4 as well. And now my c again will be equal to 0. C again 0. I will check for this. For this, the upper bound, the lower bound of 2 is 5, at least 2. 1 is less than 2, so I will got at least number, that is 2. I will got 5. 5 is between 2 and 4, no. So I will not change. Now this condition will work, this x will work, but this c will not update because x is not between 2 and 5. Okay, because it will return me 5. Now I will check for this. At least 2, or lower bound of 2, it will give me 2. It will give me 2. 2 is between the 2 and 4, so I will just got 1. Now for this, it will give me 3. 3 is between this, I will again update. Now I will check for, it will give me 7. 7 is not in between 2 and 4. It will give me 6, no. Okay, for similarly for also I got 2 as my answer. So for my next query, I got answer as 2. So again, now again I just need to, I am using black. So for my second query, I got answer as 2. Now my L is equal to 1 for 1 7 query, and this is 7. C is equal to 0 initially. I will check for this. Lower bound of 1 is 1. 1 is between. I will increment. Now I will check for this. Lower bound of 1 2. 2 is between. I will again increment. Lower bound of C. Lower bound of 1 in C array 3. 3 is between 1 and 7. I will again update this. Now I will check for this. I will go to 7, lower bound of 1 is 7. Then I will 7 is between 1 and 4, 1 and 7. I will again increment. For E, it is 6. It is 6. It is 6, right? It is 6 between this. So I will again increment. Now for F, it will give me 0. So 0, this system will not work, and we just continue because X is my size. So here answer is equal to 5. Answer is equal to 5. So this 3 to 5 is my answer, and you can see this 3 to 5 is my answer. And why I am getting this, like here lower bound is lower bound of 1 in 1 here. So you can see we have an index 1 where there is a we have index 1, there is a. For this we go to, so there is an index 2 which contain B, and this index come in between L and R. Now it will give me 3. 3 is array which contains C. 3 is, okay, so 3 is array which contains C and contain it. So I will again increment. Now for D we have index 7. We have index 7. 7 come in between L and R. I will again increment. For E I will go to 6. In 6 I have a E. So I will again increment to 5. Now for F I don't have an index. For Z I don't have an index. Like suppose if there we have a Z at index 8. Suppose for a minute we have a, so for here we have 8. 8 as our index. So when we are doing for Z, lower bound of 8, lower bound of 1, we got 8. Now we have an index 8, means in index 8 we have a Z, but this 8 is out of 1 and 7, so our C will not update. So our final answer is 3 to 5. Final answer is equal to 3 to 5. So how I am doing this? I am, first of all, I am taking a vector of int of size 20. So you can see here I am using square bracket, so it is vector of vector. Okay, I am not using this type of brackets. This is not the size of the vector, this is vector of vector. I am using square bracket. Okay, you can see I am making an array of vector in type. Okay, as well you can also describe it as like this, like this. You can also describe this as v26. Okay, now you can just use this normal bracket, because now you are defined that my vector is of vector of int. That's why you can just use square bracket as well. Okay, I hope you understand. Semicolon as well I just put. So for I is equal to 0 to si, in ith character, in sith character I will push back I plus 1. Now why I plus 1? Because I is the index in zero based indexing. In zero based indexing, I is the index in zero base indexing, and we have to do it in one base indexing. Here you can see 7, last index is 7, so we have to do one base indexing. So we will need plus 1 for one base indexing. Okay, so I hope you understand. Now we will take a vector of int of answer, because we have to return the maximum number of different character. or a number of different character, we can say. So I am taken int I is equal to 0 and I run a loop till I less than q dot size. Q is this vector of vector int I. Okay, so now my L is equal to qi, 0th index, like here 1, and my R is equal to qi, 1th character, means second character of the ith query, and here c is equal to 0. Now for j is equal to 0 to less than 26, means from j will be run from 0 to 25. 0 means a, 1 means b, similarly 25 means z. For all character I will check lower bound in my vjth array, because jth is a character array. This is v0th array, this is v1th array, this is v2th array. Okay, this is 26 array I will check for. From beginning to end I will check the lower bound of L, and decrement the vj dot begin. Here you can see I will decrement, I told you I will decrement the vj dot begin. So I will go the index, here I will go the index, and if my index is equal to size of my array, means like I am getting like here something like, if suppose if I have a value p, I have a value p which contain only 4, and if I have L has 2, R has 3, so when I will found a lower, suppose our L is equal to 20, R is equal to 30, so when we are founding lower bound of 20, then we got this array, because if I don't found a character, or if you can say if the task character of my vector is less than this L, then we just return the end of the vector, means the ended character is maybe equal to this particular character. Okay, so if you can more study out on for this regarding this overbound function on GFG. Okay, so if my x is equal to vj dot size, means we don't have ith index, then we just continue. Else while we put vj jth character, jth vector exact index in my x, and if my x is tie between L and R, x greater than is equal to L and less than is equal to R, then I will increment my c, means I found a different character. And at last, completing all the character from 0 to 25th A to Z, I will push back C in my answer, and I will increment my I. Now first I is this, then I will increment my I, and now I point to this, then I point to this, and at last it will, when I is equal to q dot size, then I just come out of the loop, and at last I just return my answer. I am running, compile it, so you can see 3 to 5 correct answer it is showing. Now I try to submit it. So you guys can see all the 1030 test cases pass out. Time taken is 0.02. Okay, very minor. Okay, very minor. Like means approximate 0 ms, you can say. So I hope you will understand this very simple approach. I am telling you this is a DP approach. Okay, there are many other way by which you can do it, but this is a simple and basic time complexity, memory complexity approach. I hope you'll understand this, but if you still have any doubt, then just comment out. I will try my best to explain you. Meanwhile, you can subscribe the channel, like the video, and please comment out if you understand the concept. And you can check out my channel for more these type of videos, and stay tuned with me guys. Thank you for watching this.